Well, look at this, we're ahead of schedule. Will be Hung from the Donders Institute. He's going to talk about neuroimaging research and the data lifecycle management.
Okay. Good afternoon. My name is Hong. I'm coming from one of the research center of Donders Institute. We are the Neuroimaging Center. There are several different kinds of researchers about neuroscience happening in our center. And in this talk, I'm going to talk about another use cases of iROD with the targets to managing the neuroimaging research data, and in particularly across the life cycle of the research. So this is the outline. Firstly, I'm going to talk about the life cycle research data management. What does it mean? And also, what are the objectives and the challenges? And to tackle those challenges, we developed this system. We use the method. This method results into two deliverables. One is the so-called research data management protocol. I will talk about that as well. And following to that, I will talk about the digital research data repository. That is, of course, based on iROD. And here I will talk more about our usage of iROD, how we use iROD to achieve our use case. And then I will go through the strengths and the weakness of this method, this approach. And then I will conclude with our future focuses. So, Lifecycle RDM. If you look into different kind of research, you can sort of structure the research into 4 steps, more or less. And those 4 steps, including the initial of the research. For example, researchers are getting some idea how to do the researches. They look into some open data to get some ideas to go on with their spatial objective. And then the next step would be to start doing the data acquisition, to get the data he needs to perform the research. And when they have the data, of course, the next step is the data analysis. And finally, the final objective of the research is to create a publication. And then we'll eventually go into the next cycle of the research. So when we talk about lifecycle RDM, we are actually talking about a research data management that spans the entire research lifecycle. And of course, the objective of this approach is to address 3 things. The first is the long-term data preservation. Secondly, the scientific integrity, which is going through a so-called scientific process documentation. And finally, to share the data for the open access, that is about data publication. The challenges. Those challenges are very related to our own institute. But I would say those are could be very generic to different research disciplines. Our institute is well, it's not very large, but it consists of 600 researchers. They are distributed into PI group. And every year, we have about 150 projects. And each project is associated with 1 or 2 or even more publications. And those projects are so diverse that you have different kind of approach of doing the research. And talking about organization, we have 3 centers. I'm coming from one of them. And there are 3 administrative procedures and policies across these 3 centers. So this is very complex environment in terms of organization. The second challenge is coming from the data complexities. So in the neuroscience and especially neuroimaging domain, the researchers try to get the data in different ways. For example, performing some experience that needs to create some audios and videos. For example, surveys. And sometimes there are imaging data such as MRI and also signal data such as EEG, MEG experience. And those data are collected from human beings, so they are sensitive. Sometimes they have to collect the address, the name of the subject, and so on. So they are sensitive. And if we are talking about the size of the data collected, actually, here I give you 2 extreme examples. And actually, all the use cases, all the researchers are kind of in this spectrum. So one extreme is that we have a data set with few large files, like few gigabytes of files. The other extreme is the MRI. It can be very small in terms of each file, but you got a bunch of them. So this is the data complexity. And thirdly is the user expectation. So when we talk to the researcher, what they need is something they don't need to put too much effort to realize the management, the data management. And the method should be straightforward, should be integrated well with their data workflow. So those are the challenges we are facing. So talking about the solution, the method we are trying to create is firstly we look into the life cycle again and put this 4-step into picture. And soon, and very quickly, we realize that those different steps, you need different type of data management approach and policies. And so therefore, we create the 3 types of data collections corresponding to the 3 different type of data management. So they are called collections, and just to be sure that this collection is nothing to do with the iROD collection, so there are different terms. Here we are talking about very high level and virtual collections. In the collections, researchers can put in data, files, folders. And most importantly, they can also address the collection with a couple of interesting metadata. And those collections has a state. As you can see now here, those are open box, which means their state is open. And at some point, when the researchers are happy with the organization in the collection, they can eventually seal it. And that's called closed collection. And when we are talking about sharing the data, the collection gets closed. At the same time, a persistent identifier is created to create a unique access point to that data. And within the protocol, you have to define how users interact with these collections. And therefore, we defined these 4 roles in our system. First of all, you have to separate the administrations, the people who organize, who manage the projects in the center, financial perspective. And then the other part of people are researchers who are really using the collection to perform their research. And among the researchers, depends on their access permissions, you can define the 3 roles: manager, contributor, viewer. Yeah? So the access permission is very similar to the Maastricht presentation this morning. So the manager has a very power right to assign other managers or contributor or viewers, while contributors are only capable to modify things in the collection, but not changing the authorization, etc. And the interaction between those peoples and the collections and how they work together during the research life cycle is also defined in the protocol, and that's the workflow part. And what is important things to address here is the research data management is actually the responsibility is distributed between administration and the researchers. So the responsibility, who should take what role in managing the data, is also defined here. And thirdly, the eligibility, which means who is allowed to take this responsibility. That is also specified. And everything is contained in the management domain, which we call organizational unit. So this is the protocol we defined. So the next step is to realize this protocol using iROD. That's the data management, and then the data repository here. So it's an ICT system with iRODS as a core. It's a single data management platform to enable internal collaboration through the first 2 types of collection and the external data sharing through the 3rd type of collection. And with iRODS, we perform this, we present this system with features like file-based system, which is very acceptable by researchers, a single uniform namespace. We also put some efforts to implement access control on the metadata level on the key value pairs. Authentication via the trusted identifier providers, role-based authorization, data replication for disaster recovery, of course, with rule engine, we can perform some workflow automation and the policy enforcement. So these are the 3 layers and the components in each layer. So in the following slide, I will looking into each component and highlight some spatial usage, well, not spatial, but our usage of iRODS. Starting with the storage system. As I mentioned before, our aim is to create disaster recovery. So in our system, we put 2 storage systems in 2 physical locations. There's a location A and B. And on top of the storage system, we simply mount this onto a file server. And through the file server, we can export the storage outside to the iROD. And in the iROD layer, we use coordinating resources for the data control, like this, the very top layer of resources. And underlying, we have the different vault or data resources for the load balancing. And you can also use this approach to define how much space an organizational unit as a boundary of the administration can use, because that's usually reflected into the financial perspective. And together with the namespace I'm going to talk about, you can actually control the data flow like this way. So it depends on the namespace of the data objects going into the iROD system. You can assign to different data locations. This is the namespace we have in our system. So basically, we use the namespace to structure the hierarchical organization between the institute and the researchers' collections. On the collection level, we have metadata stored in key value pairs. And on each level of namespace, we can use the rule, we can create corresponding groups to implement different roles and authorization. Another thing I would like to mention here is this approach of accessing iROD from the client. So basically, we realized that there are a lot of business logics which are quite complex to be implemented by continuous interacting with iROD. So the approach we take is that we just combine all the complexities into one rule, and that deploys on the iCAD server. And the benefit is that you can create some RPC-like interface for clients to build up the applications. So here is just an example for someone want to change the metadata of a collection. So basically, from the client, you just put in the collection name and the attribute of the metadata. On the server side, you can implement a lot of logics in it. For example, here I show you how to put a filter on those attributes that the common user is not allowed to change. And you can also verify the attributes against your controlled vocabularies, for example. So making sure that your collection is not messed up with some useless values of attribute. So we use this approach for a lot of things like provisioning the user, provisioning a collection, changing the metadata, etc. Talking about authentication, we use the authentication. Well, firstly, we don't store user credential in our system, so therefore we have to go through the so-called federated identity provider for user authentication. And when the first time user authenticate to our system, there's a procedure behind to provision the user in iRODS and also the underlying system to facilitate the PALM authentication. And through this approach, we also provide one-time password for data access. I will come to that later when we talk about user interface. Event logging. Well, it's very interesting to see this morning people are presenting the messaging queue for doing the auditing and logging. And actually, we took this approach to facilitate the logging mechanism in our system. It's pretty trivial. So basically, iCAD is generating logs in so-called RODS log file. So we just took this opportunity and putting into the policy enforcement point to write out some messages that allow us to do the auditing and logging in the future. And that's it. And a separate process is a file bit. You use the file bit, you can continuously looking into the file and only parse the data you want and bring it to the elect search. So with this approach, the RODS log and file bit is kind of disconnected with each other, so loose coupling. So you don't have to worry about the messaging are being blocked, and then the client action is not finished successfully. Another thing is that if you keep the RODS log in a safe place, eventually you can rebuild the whole history about your repository in the future. User interfaces. The very important feature of our system is that we tend to separate, and we actually separate, the data access interface from the collection management and user management. So on top of iRODS, we built a web portal that is made for managing the collection and user profiles. For the data access, we do have several different approaches. For example, we use WebDAV for normal researchers to access the data in an easy fashion. The second way is to use the native iRODS protocol. But our researcher is not, because it's very fast, but our researcher is not capable to understand and to learn these command line tools. So therefore, we have to build up something on top of it to create some nice looking interfaces. But in addition of the nice looking interface, we can also use this way to create some intelligence for transferring a large amount of data. Yeah, so in addition to that, to the interface, we create the internal job manager queue. So the interface provides a way to select, to define the transfer task, and then send into the job queue. The job queue will take it and initiate the transfer agents to use iRSync to intelligently transfer the data between a local storage and the repository. And because this is using iRSync, if something goes wrong in first trial, the next trials can pick it up and save your time of transferring data. Okay, the strengths and weakness. So our system, it started by taking the scientific administration workflow into account. And we try to fit this workflow, this research data management into the existing institute workflow. And the institute is large and heterogeneous. Next to it, it also provides sufficient functionality for sharing the data when you publish a paper. And most importantly, nowadays, funding agencies starting to ask providing data management plan along with your proposal. So our system can help researchers to implement data management plan. The weakness. So far, we don't have any tight integration with the data analysis facility, which is very important for researchers. Also, the management is only on the collection level. We think that collection, the researcher has all the freedom to organize the data in different ways. So far, we don't enforce any organization in the collection itself. But I can imagine with this standard way of organizing data, you can easily share the data and also implement some machinery on top of it. Our future focuses, of course, we want the system to be used also as part of data analysis facility at some point. Secondly, we only accomplish some part of FAIR principle, like we have the persistent identifier for the public data. But the full FAIR principle is not yet in our system, and so we want to look into that direction as well. And thirdly, now we are focusing on neuroimaging research domain. However, we believe that the approach is, can be generic enough for other research disciplines. So we want to see how our protocol and digital system can be reused by other researchers. In summary, we structured the RDM workflow, and this workflow covers the entire research life cycle. In this workflow, both the researchers and administrators are involved, and they take part of the responsibilities for the data management. And this workflow is specified by the protocol, and with the help of iRODS, we successfully implement it in a digital repository. And finally, this is the website. If you are interested in our system, how it looks like, you are welcome to visit. Thank you.
We have a few minutes. All right. All right, if you're next, come on down. Thank you.